Section 517.13 of the National Electrical Code states that in patient care areas of hospitals, clinics, and similar facilities, raceways for electric conductors shall be metal. This section mandates that all raceways for electrical conductors in patient care areas must be constructed of metal. Raceways are defined as enclosures designed to contain and protect electrical conductors, examples of which include conduits and cable trays. Consequently, the raceway system for light switches within patient care areas must be made of metal. The raceway system encompasses the conduit boxes and fittings that establish the connection between the switch and the electrical panel. The NEC does not explicitly mandate the use of AC cable in patient care areas. AC cable is a type of flexible cable frequently employed for branch circuits. However, if AC cable is utilized in patient care areas, it must be installed within a metal raceway system. Failure to install light switches in patient care areas within a metal raceway system may lead to the inspector failing the electrical inspection. This could result in delays in the facility's opening or necessitate expensive retrofits. There are hospital-grade switches. Hospital-grade switches are specifically engineered for application in patient care areas and comply with the requirements of the NEC. They are manufactured using durable materials and incorporate features designed to mitigate the risk of electrical shock and infection. To preempt potential issues during the electrical inspection, it is advisable to install light switches in patient care areas in compliance with Section 517.13 of the NEC. This entails employing a metal raceway system with AC cable installed within the raceway if desired. The use of hospital-grade switches is recommended to ensure that the installation adheres to the highest standards of safety and reliability. Firstly, consider the purpose of Section 517.13 of the NEC. Its primary aim is to enhance electrical safety in patient care areas where patients may be more vulnerable to electrical hazards. Secondly, the requirement for metal raceways is rooted in their superior grounding capabilities compared to non-metallic alternatives. Metal raceways provide a lower impedance path for fault currents, facilitating the rapid operation of overcurrent protective devices, such as circuit breakers, to clear faults and minimize the risk of electrical shock. Thirdly, the term patient care area has a specific definition within the NEC. It refers to any space intended for the examination or treatment of patients. This includes, but is not limited to, exam rooms, operating rooms, recovery rooms, and patient rooms. Fourthly, the definition of raceway is crucial to understanding the scope of Section 517.13a. As previously mentioned, raceways encompass conduits, cable trays, and other approved channels designed to contain and protect electrical conductors. Fifthly, the NEC permits the use of various types of metal raceways, including rigid metal conduit, intermediate metal conduit, and electrical metallic tubing. The selection of the appropriate raceway type depends on factors such as the specific installation conditions and the level of physical protection required. Sixthly, while Section 517.13 mandates metal raceways, it does not dictate the type of wiring method employed within the raceway. Both individual conductors and cables, such as AC cable, are permitted, provided they are appropriately rated for the application and comply with other applicable NEC requirements. Seventhly, if AC cable is used within the metal raceway, it must be securely supported and protected from physical damage. The NEC provides specific requirements for supporting and securing cables within raceways. Eighthly, the exception for AC cable is not a blanket exemption. The NEC stipulates that if AC cable is used in patient care areas, it must be installed in a metal raceway system. This ensures that the cable is adequately protected and grounded. Ninthly, the inspector's assertion that there is no such thing as hospital-grade switches is incorrect. Hospital-grade switches are readily available from reputable electrical manufacturers and are specifically designed to meet the stringent requirements of healthcare facilities. Tenthly, hospital-grade switches undergo rigorous testing and certification to ensure their reliability and safety. They typically feature robust construction, corrosion-resistant materials, and tamper-resistant designs. 11thly, hospital-grade switches are designed to minimize the risk of electrical shock and infection. They often incorporate features such as sealed housings and antimicrobial coatings to prevent the ingress of contaminants and inhibit the growth of bacteria. 12thly, the use of hospital-grade switches is not only recommended but may be required by local codes or healthcare facility policies. It is essential to consult with the local electrical inspector and facility management to determine the specific requirements for electrical devices in patient care areas. 13thly, failing to comply with Section 517.13 of the NEC can have serious consequences. In addition to delaying the facility's opening or requiring costly retrofits, it can also create a hazardous environment for patients and healthcare workers. 14thly, electrical inspections are conducted to ensure that electrical installations comply with the NEC and other applicable codes and standards. Inspectors are responsible for identifying and correcting any deficiencies that could pose a safety risk. 15thly, if an electrical installation fails an inspection, the facility owner or contractor is typically given a period of time to correct the deficiencies. A re-inspection is then conducted to verify that the corrections have been made satisfactorily. 16thly, in some cases, repeated failures to comply with electrical codes can result in fines or other penalties. It is therefore essential to ensure that all electrical work is performed by qualified and licensed electricians and that it complies with all applicable requirements. 17thly, when selecting electrical equipment for patient care areas, it is important to consider not only the NEC requirements but also the specific needs of the healthcare facility. Factors such as the type of patients being treated, the level of care being provided, and the potential for exposure to moisture or other contaminants should all be taken into account. 18thly, electrical safety in healthcare facilities is a multifaceted issue that requires a comprehensive approach. It is not enough to simply comply with the NEC requirements. Healthcare facilities must also implement robust electrical safety programs that include regular inspections, maintenance, and training. 19thly, healthcare workers should be trained to recognize and respond to electrical hazards. They should also be provided with appropriate personal protective equipment, such as insulated gloves and footwear, to protect themselves from electrical shock. 20thly, electrical equipment should be regularly inspected and maintained to ensure that it is in good working order. Any damaged or defective equipment should be repaired or replaced immediately. 21stly, healthcare facilities should have a written electrical safety plan that outlines the procedures for preventing electrical accidents and responding to emergencies. The plan should be reviewed and updated regularly. 22ndly, it is important to remember that electrical safety is everyone's responsibility. By working together, healthcare facilities can create a safer environment for patients, healthcare workers, and visitors. 23rdly, when working with electrical systems, always de-energize the circuit before commencing any work. Use appropriate lockout/tagout procedures to prevent accidental re-energization. 24thly, never work on electrical systems while standing in water or on a wet surface. Water is an excellent conductor of electricity and can significantly increase the risk of electrical shock. 25thly, use insulated tools when working on electrical systems. Insulated tools provide an extra layer of protection against electrical shock. 26thly, if you are not comfortable working on electrical systems, do not attempt to do so. Contact a qualified and licensed electrician to perform the work. 27thly, always follow the manufacturer's instructions when installing or using electrical equipment. Improper installation or use can lead to electrical hazards. 28thly, never overload electrical circuits. Overloading can cause the wiring to overheat and potentially start a fire. 29thly, use ground fault circuit interrupters in areas where there is a risk of water exposure, such as bathrooms and kitchens. Ground fault circuit interrupters can detect ground faults and quickly shut off the power to prevent electrical shock. 30thly, inspect electrical cords regularly for damage. Damaged cords can pose a fire hazard or shock hazard. 31stly, do not run electrical cords under rugs or furniture. This can damage the cords and create a fire hazard. 32ndly, keep electrical outlets and switches covered when not in use. This will prevent children from sticking objects into the outlets and getting shocked. 33rd, teach children about electrical safety. Explain the dangers of electricity and how to avoid electrical hazards. 34th, if you see a downed power line, stay away from it and call the power company immediately. Downed power lines can be extremely dangerous. 35th, in the event of an electrical emergency, call 911 immediately. Be prepared to provide information about the location of the emergency and the nature of the problem. 36th, consider the long-term implications of electrical installations. Choosing high-quality materials and following best practices can minimize the need for future repairs and replacements. 37th, regular maintenance of electrical systems is essential for ensuring their continued safety and reliability. This includes inspecting wiring, tightening connections, and replacing worn or damaged components. 38th, the NEC is constantly evolving to reflect new technologies and best practices. It is important to stay up to date on the latest code changes to ensure that electrical installations comply with current requirements. 39th, consider attending continuing education courses on electrical safety and the NEC. These courses can provide valuable insights and help you stay informed about the latest developments in the field. 40th, consult with qualified electrical engineers and contractors when designing and installing electrical systems. Their expertise can help you ensure that the installation is safe, efficient, and compliant with all applicable codes and standards. 41st, proper grounding is crucial for electrical safety. Grounding provides a path for fault currents to flow back to the source, allowing overcurrent protective devices to quickly trip and clear the fault. 42nd, the grounding system should be properly sized and installed to ensure that it can effectively handle fault currents. The NEC provides specific requirements for grounding electrode systems. 43rd, bonding is the process of connecting all metal parts of an electrical system together to create a low impedance path for fault currents. Bonding helps to minimize voltage differences between metal parts, reducing the risk of electrical shock. 44th, surge protection devices can help protect electrical equipment from damage caused by voltage surges. Surge protection devices should be installed at the service entrance and at sensitive electronic equipment. 45th, arc fault circuit interrupters are designed to detect arc faults, which are a common cause of electrical fires. Arc fault circuit interrupters should be installed in branch circuits that serve bedrooms and other areas where people sleep. 46th, tamper-resistant receptacles are designed to prevent children from inserting objects into the receptacles and getting shocked. Tamper-resistant receptacles should be installed in all areas where children are likely to be present. 47th, lighting control systems can help reduce energy consumption and improve the ambience of a space. Lighting control systems can be programmed to automatically turn lights on and off based on occupancy or time of day. 48th, emergency lighting systems are designed to provide illumination during power outages. Emergency lighting systems should be regularly tested to ensure that they are in good working order. 49th, fire alarm systems are designed to detect fires and alert occupants to evacuate the building. Fire alarm systems should be regularly inspected and maintained to ensure that they are functioning properly. 50th, communication systems such as telephones and intercoms are essential for healthcare facilities. Communication systems should be reliable and easy to use. 51st, data cabling systems are used to transmit data between computers and other devices. Data cabling systems should be properly installed and maintained to ensure that they provide reliable data transmission. 52nd, consider the use of energy-efficient lighting and appliances. Energy-efficient equipment can help reduce energy consumption and lower utility bills. 53rd, implement a program for recycling electronic waste. Electronic waste contains hazardous materials that can pollute the environment if not disposed of properly. 54th, consider the use of renewable energy sources, such as solar panels. Renewable energy sources can help reduce reliance on fossil fuels and lower carbon emissions. 55th, promote energy conservation among employees and patients. Simple actions, such as turning off lights when leaving a room, can make a big difference. 56thly, conduct regular energy audits to identify opportunities for energy savings. Energy audits can help you identify areas where energy is being wasted and develop strategies for reducing energy consumption. 57thly, establish a sustainability committee to oversee the facility's environmental initiatives. The Sustainability Committee can help to develop and implement policies and programs that promote environmental stewardship. 58thly, partner with local organizations to promote sustainability in the community. By working together, you can make a greater impact on the environment. 59thly, the inspector's responsibility is to ensure compliance with the NEC and local codes, thereby promoting safety and preventing potential hazards in electrical installations. 60thly, understanding and adhering to the NEC is paramount for all electrical work to safeguard individuals and properties from electrical dangers.